write the augmented matrix. 2, use the row operations to get an equivalent matrix in row echelon form. Use the how to get a 1, how to get a 0 in the proper order. Step 3 is to use back substitution to solve for the variables. Answer your solution in an ordered triple. So our first full system of equations that we're going to be solving using matrices is 3x plus y minus z equals 9, negative x minus y plus 3z equals 3, and x plus 2y minus z equals 0. So the first thing I want to do is write an augmented matrix for this system. So we have 3, 1, negative 1, 9, negative 1, 3, 3, 1, 2, negative 1, 0. Now that I have an augmented matrix, I would like my matrix to be in row echelon form. The first thing I want is a 1 up in the upper left-hand corner. I have two ways of getting a 1. So in order to get a 1, I can either switch two rows or I can multiply the row by its reciprocal. If I multiply this entire row by the reciprocal of 3, which is 1/3, I'm going to get fractions. And then I'm going to have fractions throughout the whole thing, which is fine, but really annoying. So instead of doing that, what I would prefer to do is I would prefer to see if I have an already convenient 1, which I do. I have one in the row 3. So if I just take row 1 and interchange it with row 3, I will get the 1 exactly where I want it. So row 2 isn't changing at all, so I'm going to go ahead and put row 2 in. Row 1 and row 3 interchange places, so the row 1 is going to end up at row 3. Row 3 will end up at row 1. So let's do a little progress report. Do I have the 1 where I want it? Check. Do I have zeros below it? Well, no, so that must be my next step, to get zeros below it. So what is the rule to get a 0? In order to get a 0, I have to take the opposite sign. So let's focus on the negative 1 first. What is the opposite of negative 1? Well, positive 1. Times the row with a 1 in it. What's the row with a 1 in it? Well, the first row is the row with a 1 in it. Add it back to row 2 and put it into row 2. At the same time, I'm going to work on the 3. I would like this 3 to become a 0 as well. Go back to the rule that says how to get a 0. You take the opposite of 3, which is negative 3, times by the row with a 1 in it. Which is the row with a 1 in it? The positive 1, that's row 1. Add it back to the row, put it back into the row. Now this one requires a lot of steps of work, so I'm going to go ahead and use the right side of my screen to do that. So I have 1 times row 1 plus row 2. I'll do this one horizontally and the other one vertically. So 1 times row 1, that's 1, 2, negative 1, 0. And row 2 is negative 1, negative 1, 3, and 3. Once I have those all written out, I can add it. 1 times 1 is 1, minus 1 is 0. No real surprise there. That's what we were trying to have happen. 2 times 1 is 2, minus 1 is 1. 1 times negative 1 is negative 1, plus 3 is 2, and 0 plus 3 is 3. So on my next matrix, row 1 is going to stay the same. So 1, 2, negative 1, and 0. Row 2 is going to be replaced with 0, 1, 2, and 3. And let's see, let's do the other one, the other method. It doesn't really matter which method you like, just pick one and stick to it. I'm just trying to show you both so you can get used to the one you like. So negative 3 times row 1 is negative 3, negative 6, positive 3, and 0. Add it to the row 3. So I'm getting 0, negative 5, 2, and 9. Okay, let's do a little progress report here. Do I have the 1? Yes. Do I have 2 zeros below it? Check, check. Do I have a 1? Check. This accidentally happened for us. I didn't force that to happen, but it was already a 1, so I'm not going to do anything there. So the next thing I need is a 0 below that 1. So I need to use the rule for getting a 0. So in order to get a 0, I have to take the opposite of negative 5. The opposite of negative 5 is positive 5 times the row with a 1 in it. Which is the row with a 1 in it? Well, if you look up and down in the column 2, where the negative 5 is, the row with the 1 in it is row 2. And even if the first row had a 1 in it, we're talking about the row with the 1 down the diagonal. So if you're ever using the second column, you need to use the second row to be the row with the 1 in it. Add it back to the row, put it into the row. Okay, so I can either choose the horizontal or vertical method. I'm going to go ahead and do the horizontal again. Or, I'm sorry, the vertical. So we have 5 times row 2, which is 0 times 5 is 0, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. So I add down 0, which means I'm not messing with the 0 that was already there. Add down 0, that's what I was hoping to have happen. That shouldn't be a big surprise there. 12 and 24. So in my next matrix, row 1 and row 2 stayed the same, so go ahead and put those in. Row 3 is the one that I was changing, and that changed to 0, 0, 12, 24. So let's do our little progress report. Do I have a 1? Check. Do I have a 0 below it? Check, check. Do I have a 1? Check. Do I have the 0 below it? Check. So what is the next thing I'm looking for? Well, I want that 12 to become a 1. So what is the rule to make a 1? Well, I could switch it with another row, but that actually really only is helpful for the first step. So the rule to get a 1 that I have to use here is multiply by the reciprocal. The reciprocal of 12 is 1/12. I know a lot of times students don't like to think of fractions, so we can think of it, instead of a multiply by a fraction, we can think of it as a divide. Notice row 1 and row 2 aren't being manipulated at all, so I'm going to keep those the same. Instead of taking 0 times a 12th, you can just think of 0 divided by 12 as 0, 0 divided by 12 is 0, 12 divided by 12 is 1, 24 divided by 12 is 2. And look at that progress report time. Do I have a 1? Check. Do I have a 0? Check, check. Do I have a 1? Yes. Do I have a 0? Check. Do I have a 1? Yes, I have everything in the order that I wanted in. This matrix is now said to be in row echelon form. To finish this, I'm going to put my matrix in row echelon form back into the equations. Okay, I would like to change these equations to solve for the x, to solve for the y, and to solve for the z. Because we had 1's down the diagonal, I know these will always be 1x, 1y, and 1z. So the first equation is x is equal to, I'm going to have to move these two things over, negative 2y plus z plus 0. Notice that the positive 2y moved to the other side and became negative. The negative z moved to the other side and became positive, and the 0 stayed the same sign. On the second equation, y equals, I have y equals the 2z needs to move to the other side, so it changes sign. The 3 was already on the right hand side, so it doesn't change sign. And the last one, z equals 2, is actually already solved. So my solution already has a z. Z is 2. In order to find out what the y and the x are, I'm going to plug in the z into the red equation to solve for y. So I have y equals negative 2 times z, but z is 2, plus 3. So that gives me y is equal to negative 4 plus 3, or negative 1. To solve for x, I'm going to use the x equation, plug in y is equal to negative 1, and z is equal to 2, and evaluate. Negative 2 times negative 1 is positive 2, plus 2 plus 0, so x is equal to 4. Back substitution, you're starting with the z and solving back until you get to the x. So positive 4, negative 1, comma 2 is my solution. You are welcome to check your work. You don't have to, but in order to check your work, what we're going to do is we're going to go all the way back up to the original problem and take my solution and plug it into each equation and see if it works. So I'll show this to you once, but I'm not going to show it on every problem. So we have 12 minus 1 is 11, minus 2 is 9. It does work. Negative x minus y plus 3 times z is supposedly equal to 3. So that's negative 4 minus a negative 1 plus 3 times 2. So that's, let's see, negative 4 plus 1, that's negative 3. Negative 3 plus 6 is truly 3. So this one works as well. The last one we have x, which is 4, plus 2 times y, which is negative 1, minus z, which is 2, is supposedly equal to 0. So let's see, 4 minus 2 is 0. Okay, so you could do that in your head, or you could write it out, or you don't even have to check it all. But if you wanted to check now, you know how.